Is your lab's central vacuum system a dinosaur? At one time, a big, lumbering approach like central vacuum may have ruled the Earth, but the environment has changed. These oversized, inflexible systems are headed for extinction. Oh sure, if you need basic vacuum for simple filtration or aspiration, it provides adequate suction. But what about other applications, like evaporations in the chemistry labs? If you're trying to maintain constant conditions and someone in another lab opens a port to aspirate liquids, the pressure spike can ruin your run. Making matters worse, the vacuum from a central vacuum system isn't strong enough for many chemistry operations. You end up paying twice for vacuum, once for the central vacuum system and again for vacuum that actually serves your scientific needs. Central vacuum is neither flexible nor modular. In today's multidisciplinary science buildings, the needs of each lab change over time. The only way to get flexibility from a central vacuum system is by overbuilding. You have to size the pumps and pipes to support all possible future users, and then run those expensive copper pipes throughout the entire building. Many systems even create vacuum around the clock, even when the building is empty, just so it's available in case anyone is working nights or weekends. That wastes a lot of electricity and contributes to high operating costs. Central vacuum is also a problem when you need to isolate applications. Think about it. The central vacuum system sucks the vapors from your project behind the walls, where they may contaminate research in other labs and condense into a toxic sludge in the pipes that reduces building vacuum performance over time. You certainly can't use central vacuum in a BSL-3 lab. You need to isolate your operations. For all these reasons, many modern lab buildings are being designed without central vacuum systems. But if central vacuum is headed for extinction, what are your options? Not water aspirators. They can waste and pollute 50,000 gallons of water per year per unit. Literally hundreds of thousands of gallons or more in a lab building. Dedicated pumps for each operation are a good option for the occasional user, or where the ultimate in control is needed for specialty applications like evaporating complex mixtures. But most labs just don't have the bench space or the budget for a single pump for each scientist. The modern option is a VacuLan local vacuum network from VacuBrand. With a VacuLan network, a single, quiet, oil-free vacuum pump sits under your bench or fume hood and supplies vacuum to several workstations in the lab. A VacuLan network can supply vacuum that's deep enough for nearly all lab operations, and VacuLan ports protect against sudden pressure spikes if an adjacent port on the network is opened during your run. You install VacuLan networks quickly with simple tools, only where you need vacuum in your building, and produce the vacuum on demand. You don't have to overbuild to ensure flexibility in the future. You can always add vacuum as you need it, where you need it. It's the ideal solution for lab renovations and flexible new construction. The VacuLan network can even be configured for control at bench ports that's comparable to what you would get from a programmable dedicated pump. Deep, stable, controllable vacuum. If you don't need that control now, it's no problem. Just add it when needed. The individual ports are as modular as the overall network. VacuLan technology will even support your green building objectives. A VacuLan network operates on demand, so it can save as much as 90% of the energy needed to produce vacuum 24/7 for building-wide vacuum systems. And the local vacuum pumps can collect waste vapors from vacuum applications right in the lab for recycling or proper disposal, instead of venting them into the atmosphere. So say goodbye to the age of the dinosaurs and welcome a successor that is better adapted to the modern world. For more information about VacuLan local vacuum networks, visit us at vaculan.com.